If a unit goes buzz, it's the run cap. If a unit goes buzz, it's the run cap. If a unit goes buzz, buzzy, buzzy, buzz, it's the Chinese run cap. If a unit pumps down, it's the TXV. If a unit pumps down, it's the TXV. It pumps down, down to the ground. It's the daggone TXV. If a unit freezes up, it's a good man. If a unit freezes up, it's a good man. They say all brands do it, but man, screw it. It's my song, so it's a good man. Words of wisdom from a super tech. I will teach you about my red flags and measure quick. So teachers teach about superheat, but do they teach you at which Arby's to eat? I do. If the fan won't move, it's the bearing. If the fan won't move, it's the bearing. It may be sleeve or it may be ball, but it's daggone, it's sure the bearing. If the suction line's hot, just add gas. If the suction line's hot, just add gas. The superheat's high, high as the sky, so you better add gas. If the compressor breaker is tripped, then it's grounded. If the compressor breaker's tripped, that old sucker's grounded, so don't hold that breaker closed from experience. Words of wisdom from a super tech. I can teach you about my red flags and measure quick. Teachers teach about superheat, but none of them know the best Arby's to eat at. But I do. And that's why you listen to me, because I do. Well, hello, everybody, and welcome back to the HVAC Shop Talk podcast. I am your host, Zack, Psioda, and we're here because we love air conditioning, and we can't get enough of it in our everyday work lives. So we're back here on Sunday night to get some more of it. So I welcome you all to the show. I see we have a lot of people out there in the chat and tuning in here, so make sure you hit that poll up in the chat, the live chat here. If you watch it after the fact, you won't be able to do this, but if you're in the live chat, which is the place you want to be, during these shows, if you can get to the live chat, there's a lot of fun, entertaining back and forth there, and you will love it. And you can choose to vote on this poll. We have 11 votes so far. Here's the poll. It says, what is your favorite part of HVAC? Your choices are the science. Trust the science. That's a different connotation for that. Meeting and working with customers. That's nice, right? Sometimes. Well, except for the guys who do commercial. They're antisocial sociopaths. Selling jobs, and system design. So far, we don't have any engineers out there. We just have the science is leading 91%. I guess you tuned into the right show. And meeting and working with customers is 9%. And then there's no votes for the other ones at all. So I want you guys, I look down there, we got Susie. Let's go to our chat here, which is what I like to do. Let's go to the chat, and we're going to chat with the chatters. And I wish I could get the chat on the screen. Next time, I'll have to do that somehow. And you know what? Being me, I love to force things to happen in the moment. So I'm going to see if I can do it right here, right now, because I like for you guys to follow along afterwards. I know you can follow along in the chat afterwards. You can open it up on your computer if it's available, or your MacBook, Chromebook, if you will. Any one of those different things that are computers, allegedly. I don't know about the Chromebook. So see if I can bring it in here. Let me see if I can do some magic here. Chrome. No, I'll have to do the whole, and I don't want to do the whole thing. So we'll figure it out for next time then. All right. I tried my best. Let's go to the chat here. Everything's sounding good out there. I hope everything sounds great. Oh, we got another vote. We got a vote for system design. Who voted for system design? I just got to know. Someone came in there. Now it's only 83% for science. It's like y'all don't even like science. So we have Susie Dunn. That's one of our finest watchers. Susie is top tier, along with the only other woman that ever looks at this channel, Jessica. Hey, Jessica and Susie. We have Marco Nantel, my Bostonian sounding friend. And I remember when you called in, I watched that video the other day. That was a good call. I enjoy that. We're going to do calls again one day. It's coming up real soon. The phone works now. Everything patched in. We'll be able to do that again very soon. Marco says, I think I see a baby bird in your beard. A baby bird could be in there for a couple of weeks and I wouldn't know about it. Yeah, it would. There's probably some barbecue sauce in there somewhere. You know, Carolina Treat sauce too. There's probably a whole bunch of stuff in there. Actually, I hardly ever use Carolina Treat, but it's pretty good. We have Clint Glasgow. We have Scott Jones asks, how long has this been going on? If he's talking about this show, just a few minutes. If you're talking about YouTube, it's been about 20 years. And the internet is probably about 40 years or so. There's probably been some form of the internet for around 40 years. I don't know which question I should answer. So, Susie has sent in a $2, I guess it's a super thanks or sticker or something. It's yeah. And that's a good way you can support this show if you're enjoying the show and you say, hey, Zach's doing a great. Uh-oh, we kind of disappeared for a second. That was scary, and I came right back. Okay. So you can super chat to the show just like Susie has done to support it. But easy ways to do it are liking the video, subscribing. That's the best way to do it. To do these live streams, I like it just to be subscribers. I don't like people coming in here and just starting to chat about random stuff. We don't want that chat bombers. We don't need the chat bombers. So you have to be subscribed to the channel to chat here. So this Sunday show is what Scott was talking about. So I restarted this, I think it was 3 or 4 weeks ago. I've been doing it for 3 or 4 weeks. So we're going to do Sunday and Wednesday with a new dedicated purpose, a new drive that is unequaled. You have to go back in time. We're going to make it like it was a few years ago. Make sure we get this show top shelf. We're going to have some funny stuff, but we're going to have some education, Zack Psioda style, which is real world blue collar education. So it's still legit, though. It's not like it's wrong information. It's just from me instead of like an actual accredited teacher. Hey, let's see. Jessica, Marco. Let's see if we got anybody else out there. Brandon, Brenny. I see you there. That's my Midwestern friend, Brandon. He stays in the basement. He says, oh, a lot or something like that. Oh, gosh. Oh, gosh. Brandon's here. Oh, gosh. So let's see what we got. I think that's about everybody. I want you guys to keep voting on that poll. We got 14 votes now. Uh-oh. The science is falling now. We have more working with customers, 14%, and system design is 14%. No one likes selling jobs or just won't admit it here because we have a thing against sales. Maybe it's not a sales-friendly environment. Like I always say, sales is good. You want to be an ethical salesman and what I call old school sales. OP. Okay, OP. That's what the Midwesterners say. Go to the chat here. Scott Jones said, missed the Bible study show. It would be nice to have some Bible study stuff back. I'm climbing back into this thing slowly but surely. Hey, man, I love the Bible. It's the only book I'll read, basically. Besides, I read How to Win Friends and Influence People as an audiobook, if you listen to this show. So, all right, what we're going to do tonight is we're going to go into a mode I like to call learning mode. And we're going to see how well this works. Haven't done this in a while, but I think it's something that I can do. I can give back to the HVAC community in a way that is specific to me. I'm not a teacher of HVAC. I never said I was a teacher. People who watch me know I'm not a teacher, but I do have some information I've gathered over the 25 plus years in the trade. In fact, it's 30. Wow, it's 31 years. That's amazing. I should know more actually by now. So it's 13 years or something. But I'm going to give you my take on what I would do in certain situations, why I justify that. And you guys can chat back and forth. That's what live stream about. You can say, hey, Zach, I don't think you're right at all. And I'll be like, hey, it's possible. What you got? And you can tell me why I'm wrong. And we'll all get smarter together over time. And I can just say, hey, the creatures dance like us. Evidently, he subscribes. Welcome to the show. Wow. Fantastic. So I'm going to start this off, and we're going to talk about, well, first of all, I started out wanting to talk about like service stuff in the field of the real world, which would be mismatched stuff and all sorts of just horrendous systems that you come across. But I started to think to myself, how are we going to understand what to do on those systems, especially new guys, if we don't go into the basics of what we have to do? And the reason why I want to do this is I realize that if you're a new guy in HVAC, you might be sitting there saying, hey, I don't know anything what you're talking about here. Like, there's still new guys out there that knows that air goes into one end of the box and comes out and it's colder, but they have no idea what's happening. They have to learn that stuff. And that's just normal human stuff. You don't wake up in the morning knowing about thermodynamics. I say that word to make it sound smart, but it's just cooling stuff down. That's all it is. There's nothing fancy about it. There's people that make it sound fancy. Those are real teachers, but I'm going to make it sound attainable, I hope. So, no, that sounds gross. Gross? I think he's referring to the chat. Because it says, do you do chili and cinnamon rolls? Well, that's disgusting. So no, I don't know about that. You guys are sick. Thanks again, Susie, for the super chat. Like I said, it's a great way to support the show. Makes a big difference, especially when we get to Wednesday night and we're playing the skilled trade up. For those of you who may or may not have ever heard of that before, this is a trade show, game show. You answer questions and win prizes. Every week, their prizes are going to get better because I'll be able to put a little bit more into it. And of course, you guys show me support on these shows, which helps out too. I have a lot of tools over there, a lot of blowers and air dusters, but you know what? That's what I've been working on the tool side. So we have a lot. I have a battery-powered vacuum cleaner, like a little shop vac, and that is great for service. If you're a service tech, you probably know that already. Having a little shop vac is wonderful. So that's Wednesday night, same time, 9:15 p.m. All you have to do is come on the show. You can click a link that I'll put in the chat and actually come on the screen with me and play the game. It's a lot of fun. If you look back, if you just search Skilled Trade Up on YouTube, you'll find examples of this show. Don't be too proud. Come on here and give it a shot. I have found that people, when they come on Skilled Trade Up, these people that I thought were infallible people, not even human beings, do have limits to what they know. And that's reassuring, because sometimes you see these people on YouTube and TV and you're like, this guy, I never can be like this guy. But it turns out that guy has a bunch of weaknesses just like all of us. So if he can learn it, we can learn it. So that's how I kind of sell you on coming in and listening to this stuff in general, because knowing that it is attainable for pretty much anybody if you put effort into it. It's not like specialists are up there at the top of the field. They're just regular guys who studied and learned stuff. I mean, it's not crazy. They just work hard, and anyone can do that. Working hard is something that's available to everybody. So I think that's a great thing. So come play Skilled Trade Up and rise in the trade. They're talking about Wisconsin now in the chat. So I'll look at the chat again in like 10 minutes when the Wisconsin stuff is over with. I do suggest going to visit several Wisconsin towns. Probatubiak, Flupakak. They're all next to Pabst Blue Ribbon plant, and you'll have a great time there. I hope those names were correct. Let's get started. All right, let's get started with this. All right, I'm going to put words up, explain TXVs. I like that. We can do that at some point. We can explain TXVs and other metering devices, so I will keep that in mind. That is a good suggestion. Yeah. Oats my goats. That's funny. Someone changed their name to Oats my goats. I like that. That's pretty funny. All right. So real world HVAC systems. I want to tell you, you guys, a lot of you know this already. They're not perfect. They're not installed correctly. They're not ducted correctly. They're not charged correctly. They don't get enough air. They get too much air. The duct's too small or too large. It's not made correctly. It leaks. They left the door off of it. Gas pressure is not right. Too high, too low. Use the wrong piping. There's all sorts of things that lead to a job not being done correctly. There is no job out there that is 100% perfect. It's not possible. Number 2 says it can't be made perfect. You're not going to do anything perfectly out there in the field. And if you can kind of grasp that, you know that it doesn't matter who you are. You're going to hit those stumbling blocks along the way, but you'll be able to understand this stuff and reason through it. And you just got to stop, slow down, gain some information, not panic. Just be there in the moment saying, okay, let me see if I can understand why this isn't working. And that's what I'm going to try to do here. The idea is to get some confidence, go up there and use your reasoning and use the information that you've gathered and be able to understand why something's not performing correctly, and take the parameters which you measure, which is one thing that's big. You got to measure something to know what it does or if it's working. If you don't measure it, how do you know? And that's the old statement. What was that? Eddie Leverage's, if you ain't measuring, you're guessing. Maybe that was True Tech Tools. I don't remember, but someone said that. And it is true. So don't go in there thinking that you're just going to wave your hand over something. You can hear whistling in the grills. All these are information that you can use, but you have to verify that. If you don't measure it, it's only something that you assume is happening. So you have to have the numbers to back it up, especially when you're trying to justify explaining it in justification to a customer or to your boss. Because he's going to know, okay, is it low in air? How much air was there? Or maybe he doesn't. Not all bosses can grasp this information. Some of them aren't even built for the service side. They're just bosses. They're management that don't understand. But it doesn't make it any less important, because your confidence will be boosted by knowing this stuff. And your customer will say, hey, this guy just said a whole bunch of numbers. He must be right. I had plenty of customers that I'm pretty sure had no idea what I was talking about. But, and that's my fault. Soft skills training was skipped for me. But they understood that I was measuring and taking it seriously. And that mattered just as much as if they understood it, evidently. All right. Let's go to number 2 here. Real world HVAC systems almost always have duct issues. There is no duct system on the planet Earth that is good enough or perfect. I will say good enough. We'll say perfect. They cannot be perfect. Humans cannot create a perfect anything. You know, we can go to the Bible study and learn that. Humans are not perfect, and they'll never be perfect. Not down here anyway. There's going to be duct issues. There's going to be leaking in the duct system. No duct system is 100% tight. You can get pretty daggone close, and 99.9% if you're really taking your time with it, but not a whole lot of people really take their time with the duct system. You might have a guy out there that's masticking 1 inch of goop, which is what we call mastic where I come from, putting goop all over the ductwork until you can't even see any cracks. But you know what? It might be perfect in that moment or very close, but you know, electrician's going to crawl under it. Electrician's going to drill through it. Electricians are bad. That's what I'm trying to say. Plumbers are going to drill through it. They're going to kick takeoffs off the duct just so they can run a plumbing pipe or something. Things are going to happen to it. So even if it's close to perfect at the beginning, it's going to get worse and worse as time goes on. It's I think it's the principle of entropy. It's never going to get, and I like to chat over there. It says doggone. Is that an industry term? You better believe it. On this show it is. Number 2, duct systems and ACs. AC is what I'm referred to with number 2. They're sized outside of tolerances. All right, what does sizing outside of tolerances mean? Well, Manual J gives you a leeway. We'll just say it's plus or minus. We'll say it's plus or minus 10%. That's a little bit less than it used to be, because on one side it's plus or minus 15%. But you get it. It's 10% is your leeway. So if you have an air conditioner, because air conditioners aren't made in every single BTU size, you have half tonnages for the most part, unless it's multi-stage, because multi-stage can compensate a little bit for that. So you have your half tonnages. You have your load calculation, which someone hopefully did in your company. Let's say it's 36,000 BTUs of load on a structure. So you put in a 3-ton unit. Well, 3-ton units very rarely operate at exactly 30,000 or 36,000 BTUs. So you're going to have a particular matchup of a system. Let's say it's 34,000. 10% of 34,000 is 3,400. So you're within the tolerance there. A lot of people are not. A lot of people go overboard. It's like, I need to make sure this house cools. So even though it says 36,000 on the summary here at the load calculation, I'm gonna put in a 3.5 just to make sure. Get them through those real hot days, which seems like you're doing a good thing, but it's not. It's not a good thing because oversized air conditioners cause a lot of problems. So you want to try to hit the sweet spot. Being slightly undersized is, to me, a good thing because at least you're not going to err on the side of a house being incredibly humid. You'll have it be able to dehumidify just a little bit better through run time. And that means a smaller system is going to have to run more to do the same thing as a properly sized system. So 10%, either way, it's kind of hard to find that in the field. 50%, more like it sometimes. Real world HVAC systems almost always are not properly charged. Very rarely did I see a system that I went to service and it had a perfect charge. It may have been close, and there were some I didn't have to touch because there are tolerances for that too. Let's say you were working on a TXV system that called for 9 degrees of subcooling, and that TXV would produce 12 degrees of superheat at the outdoor unit, which usually means it was at 10% or 10 degrees at the evaporator exit. Talking about a split system here. Well, subcooling changes throughout the cycle. And for example, if you have a very hot day and they turn the AC off and they turn it back on, see what happens is the TXV opens and closes. And on a very hot day, when that coil kicks into action, the superheat's going to be potentially really high because it's going to struggle because the air coming across the coil is very hot. So basically, it's going to take that refrigerant in there and boil it real fast. And it's going to heat it up beyond that 10 degrees of superheat exiting the evaporator. So what happens, the TXV, sensing this through a little bulb on it, says, okay, it's too warm leaving the evaporator, so I'm going to open up. And the TXV opens up and refrigerant pours into the evaporator, bringing the superheat down. But what happened is the channel between the high side of the system and the low side just grew because the TXV opened up. So the subcooling is formed because that liquid refrigerant stacks before the TXV. So if the TXV opens, more refrigerant flows through, subcooling is going to come down. So on a really hot day, if it's 90 degrees in the house, your target subcooling might be 9, but what you get might be 3 or 4 because the TXV is open. So you have to account for that. And that's a lot of different metering devices will act that way because they're trying to compensate for that high superheat heading back to the compressor, which is a compressor killer. They don't want the compressor to have 30 degrees of superheat coming back because by the time it spits it out on the other side, it could be 210, 220 degrees on the top of that compressor. And compressors do not like 220 degrees. That is the danger zone because 220 degrees is on the outside, the top. The inside is going to be warmer still. So it's very, very dangerous. We'll hit one more point here. I'll reflect back on the chat. We'll continue. Real world HVAC systems almost always are not installed properly. We kind of been talking about that the whole time. They're put in without the proper adjustment kits, downflow. You ever see a downflow unit with a very special downflow kit installed out of S-Lock and some sort of angle? Well, that's because someone didn't order the downflow kit. Might have done that a little bit in my day. Because downflow kits sometimes are not available for certain units. You have to order them. And if you're at a job and it's going, and you think you can make a kit that is very similar, which you can sometimes if you're a sheet metal person, or just a person who has snips and a hammer, you can sometimes make that kit. A little bit of insulation. Don't forget that. Don't want to sweat. But things like that are left out all the time. Thermostats are wired incorrectly, so the features of the unit don't operate properly. You ever seen Y1 and Y2 wire nutted together so it runs in high all the time because somebody thought that was the solution to a problem? And maybe it worked a little bit better for some reason. Maybe they left it on Y1 and then they put a timer on Y2 because the house was real humid. So they wanted to drag out that cycle. Now, a lot of thermostats, you can adjust that too. But you see a lot of service techs in the field. I come from an older time when relays solved our problems. We didn't have thermostats that would think for us. We had to kind of design things with relays, which I think is a fun time to come from because you get a lot of, fun ideas that way. So let's look back at the chat for just a minute. We have oversized equal too much humidity, airflow before charge. That's right. That's what we're going on with this show. It's basically airflow before charge. And they're talking to Ted. Welcome, Ted. And Ryan Hughes. What's up, Ryan? Let's see. Yo, Ted, I just got a Train Quick Box I don't know what that is. So maybe I have to look up. Yeah, I like that. Okay. Yeah, that's okay. Well, that's unrelated to the show for the most part. So I'm going to continue here. First things first, hey, what'd you say out there? What is the airflow? You must have the proper amount of airflow. We'll go into why that is a little bit. But first, there's a lot of different ways that you can measure airflow. Because if you don't measure something, it doesn't matter. It does not matter what you think it is. It doesn't matter. And hey, here's my favorite part. It doesn't matter if it feels like it's blowing hard. Blowing hard is not enough airflow. If you have a 1.5 ton system, it gets a nominal 600 CFM of airflow. That's what it's designed for, with some leniencies or some, you can come in and say the specific unit matchup is designed for whatever, but 600 nominal airflow at 400 CFM per ton. So if you have 600 CFM and you have 8 different 8x10 registers with 8-inch flexes run to them off of a trunk, then they're not going to sound loud. They're going to be nice and quiet because that is slightly oversized for what you're introducing to whatever space it is I'm talking about. Use your imagination. A doggy daycare. It's a doggy daycare. I don't know why I came up with that. I think I passed something on the way home that reminded me of that. But if you take that same system and you run those 8-inch flexes out to 4x8 grills, and let's say you only had 4 of them, they're going to sound real airflowy. They're going to sound like you go in the room and say, what did you say? What happened? It's going to be really loud. And you're going to think, hey, look at all the airflow we got. Oh my gosh. Where are we going to put all this extra air? We can blow up balloons for my kids' parties. But no, you do not have enough. You have a low amount of registers, a low amount of openings that air can go through. So it's going to sound pretty bad. It's going to sound like my room here, how it sounds when the damper is closing and opening in my system because I have a zone system. And when you catch them at the right time, before they're fully adjusted, it gets to be like a freight train for like 5 seconds where it's switching over. Let's see. Quick box filters. That's what we're talking about down. Oh, AP says Quick Box is a 5-inch Train branded filter box. So is that like a media filter then? I'm curious though. So I'd like to know, is it just like a media filter? I'd like to know. Usually, if it's a media filter box, because you guys are talking about it, that can support the weight of an air handler. I don't know if that's what you're talking about, but I assume you're talking about can you sit it on top of a media filter case? Usually you can. I'm pretty sure. So Ted said don't use them, and he's trained. I think he's basically like the president of Train. So if he says he doesn't use them, I wouldn't use it. Go to the next one here. Number 4. I was worried that I only added a certain amount of slides here because I have some more for the next part of this. I'm going to tease it right now. It's about return air, guys, so get excited. But I'm happy to say that the show is going slow enough through these slides that I don't regret not putting them in on this particular show. So that's good. How do you measure airflow? In the HVAC trade, I'm talking about normal things. How will normal average humans with their normal average amounts of money be able to measure airflow? We have static pressure, very common. Vane anemometer, which is a word I love to say because I can't wait to say anemometer later in the show. A vane anemometer. We have hot wire anemometer, and there's more. Okay. I'll go ahead and tell you, we're not going to go into the more right now, but I'll show you. This is the True Flow grid. This is a very cool way to measure airflow, and a lot of you will probably be familiar with it because we talked about it before, but it uses a lot of expensive stuff and it's going to cost a lot of money. But I just want to say I've always wanted one of those because you can sit it right into the return end of a system and it will measure your airflow. And I think that's amazing. But we ain't talking about that today because that is not a normal attainable thing for normal average people. We're going to talk about static pressure. On the screen, I have a horizontal air handler pictured. You have the return plenum, a filter, a coil, the blower section, and the supply plenum. When I say static pressure, you're measuring total external static pressure. And in this particular slide, and I'll describe it for the podcast, folks, one of the probes is out in the supply plenum, and another probe is between the filter and the coil. Now, the reason it's between the filter and the coil is because that filter is added at the job. And when a machine states what its total external static pressure is, and you go to the charts, it does not include stuff that does not come with it. So if you're adding filters to the back of the air handler, for instance, like the media filter we were just talking about, you have to measure that return side static pressure in between the filter and the coil. As long as it's, and this is a unit that's pretty typical. There are units that are blow through, like the Hyperion refrigerators from Trane. They're blow through, so they're a little bit different. You reverse the blower and the coil basically inside the machine. But 99% of them look just like the one on the screen here. This one's showing a right-hand discharge and where you could measure. Now you have to drill holes in the cabinets of stuff. When you drill holes in the cabinets of stuff, make sure you have a way that is not putting a piece of duct tape over it, that you're going to seal that hole. Make it look professional. I know all of you are putting duct tape over the hole, like I have often done, so that's why I wanted to say that. I just want people to be like, hey, what's wrong with duct tape? And my answer is nothing. Because if you put like some little, they have like those little metal things you can stick in there. They have rubber grommets you can put in there. Duct tape will probably be the best thing because it'll still be stuck on there, especially if it's in the attic, because it's going to heat up all that glue and it's going to fuse and become one with the air handler. So duct tape is fine. It's approved here at Shop Talk, but that holds no value out there in the world. I just want to show you guys where you put these probes in here. So when you measure static pressure, and I'm going to get a little drink here for a second. In fact, let's take a little break real quick. I'll come back. I'm going to get a drink of my Coke and cough because I've been blabbering on here for a second. But I will be right back. Get supplies from the site that's made for the skilled trades, Supply House. Supply House is the reliable way to order plumbing, HVAC, and electrical products online. Their easy-to-use website is packed with helpful resources and the latest product info to help you get the job done right. Shop a complete inventory of over 200,000 parts from over 400 top brands and get your order delivered right to your door with fast shipping from coast to coast. Need help with an order? Get expert support and industry-leading service from the friendliest folks in the business and talk to a real person every time. Use promo code SH5 for 5% off your first order. The Yellow Jacket Titan Max digital manifold provides the easiest path to system measurements. This 4-valve manifold provides fast and accurate measurements for refrigeration and AC systems. The high-resolution backlit touchscreen display erases the need for multifunction buttons and provides clear graphical and digital measurements. It also features internal data logging. Connect via Bluetooth to the WideJack View app or MeasureQuick app for further analysis. Visit yellowjacket.com for more information. All right, we are back. I drank some Coke and I coughed a couple times, and hopefully it will last a couple slides. We'll see what happens. There's our static pressure there. We're going to go on to the actual static pressure chart. This is an example of what it might look like here on the screen. Basically, you go in the back of your installer's manual. You'll find a lot of charts that have various blower speeds and then different external static pressure measurements. And you'll line both of the things that you measured, or the one thing you've measured, which is the external static pressure, and you'll crisscross it with whatever speed that you have chosen. And you'll see on the screen here that this particular one is medium blower tap, 0.40 total external static pressure, and it shows 1175. So let's say that you had a 2-ton system, Well, that's way too high. In fact, a better example would be a larger system because that's probably more typical. Let's say you had a 4-ton system. Typically, that is 1,600 CFM. So you may have to move it up to high or medium high. If you only had a 2-ton system and you measured 0.40, you'd have to lower it down. But here's the thing. With doing static pressure, you might measure something and say, oh, it's 1175 here on the screen. So I'll follow, all the way down to low at 0.40 is 765. That's pretty close to a 2-ton. I could do that. But the thing is, when you change the blower tap, you do have to measure it again because the static pressure will not be the same at a much lower blower speed. So that static pressure is going to change and get reduced. So you have to then look at the chart again. Now, if low is too high for you, then you have a problem. You can solve that certain ways. We won't go into that on this particular video, but just be aware that you have to continue measuring until your adjustments are done. You have to stick with the adjustment after you make that final look at the chart. So welcome Randy to the show down there. I see you down there, Randy. Anyone else? Sam is here now. Sam Andrew. And I think that's everybody. I saw Ryan Hughes. What's up? Is there 2 different Ryan Hugheses in here? Oh no. This is one of them things, internet things. I think I saw 2 different ones. But anyway, you guys get the point on static pressure. It's pretty easy to do. And there are some drawbacks though. With static pressure, it's less precise. So if you have the true flow grid on your machine, it doesn't matter what blower tab you've chosen. You don't have to put any static pressure probes. You just have to measure. Well, you have to measure. There's some pressure measurements. But with that particular device, it's going to give you a really accurate look at the amount of air going into the return side of your system. So that's great. Static pressure is probably the best way to start measuring airflow because it's really attainable to everyday people. There are cheap little dual port manometers, which is what you use to measure static pressure. You can find them on Amazon. Now, you might want to upgrade to something wonderful. A lot of people like Testo. A lot of people have probes now like JobLink that have those built into them. Yellow Jacket's got their dual port manometer or separate manometers. There's all sorts of things you can choose, but they're really cheap options that'll do the job. I used one that it was Subco that was rebadged, and it was just as accurate as any other one that I had. So you can get started using something cheaper, get your airflow tips, because you need to measure static pressure with static pressure tips. And basically they're curved at a 90-degree angle, and we can go over that too at other time. If you have any questions about this, anybody out there, I should say that here face to face. If there's any questions about what I'm saying, if you are a new guy, you don't feel like going into a chat and saying, hey, I'm a new guy and I'm likely stupid and I'm going to make a fool of myself because all these guys know what they're doing and I don't. Well, first of all, none of these people here know what they're doing. I'm just kidding. We all know what we're doing to a certain degree, but ask the question. In the video description of every video I have, typically there's an email. You can email me, and if I can answer it, I'll answer it. But I bet I know a guy, if I can't answer it, that will answer it for you. There are people across the internet that I have gotten close with over the last several years of podcasting and before that on YouTube, and we'll get the question answered. And it's not a stupid question, I can tell you that, because if you get your answer and you learn something, then it was fruitful, and I'm sure it will be fruitful. Every question typically is fruitful. They may be mocked a little bit by the more advanced, but sometimes we can't help that. It's a rite of passage here. So just keep on plugging forward. We believe in you is basically what I'm getting at here. Static pressure, another drawback. Duct turbulence can affect measurement. Duct turbulence, if you have a really odd static pressure, you can, like you plug something in, it's a big system, you expect some resistance, and all of a sudden it's really low. Move the probe, try it again in a different spot, and see if that was the issue. I've had some duct systems that they kind of, especially pressure plenums, that don't have this real linear flow. A reducing trunk system is a type of system where you have a certain size duct that comes off the end of whatever apparatus you have, an air handler, and it continues to reduce. So you'll have a duct, it'll reduce down as takeoffs come off of it. And basically takeoffs are just different little branch ducts that go to wherever you want them to go for that particular job. Every time you take some air out, you reduce the size, so you keep the pressure up. And the idea is you keep the velocity up so that no part of the system has to suffer from low velocity. It's an evening out of the entire system so you can properly cool or heat and each room in a place. So that's just the duct system I like the most. And pressure plenums are a little different. If you have a pressure plenum, you might have like a 4-foot section. A lot of times you have to have a certain length before you take runs off of a pressure plenum. Even if you have like 2 large runs, let's say you have a 2-ton system, you're going to come off of it and run a pressure plenum, and it's going to branch into 2 12-inch ducts, or a 12 and a 10, or back in the day, a 10 and a 10, or 10 and an 8, really far back in the day. But say you're branching 2 off, if they're really close to the air handler, it's going to cause a lot of turbulence there. Just imagine water flowing into a box, deadheading against the back of the box as soon as it comes out of a water spigot. That crap's going everywhere. So that's what's going to happen with the duct. So you could have these little eddy currents inside this box. There's a little swirling effect. If you could see it, it'd probably be pretty cool. But you can't see it, and that's the problem. So move the probe around and see if you have some better luck. Especially if you think duct system might be problematic. Like deadhead tees right off of a machine is pretty bad. They add a lot of effective length to a duct system. So typically you come off X amount of feet in the perfect world, and then you'll go into something like a Y. Because if you imagine, if you're going to a deadhead T, air is hitting it. If you imagine a Y, the Y can actually smoothly separate the air. So it's a lot easier for air to move. It's just like water. Just easy for it to move. It's just logical. If you put 90-degree turns that don't have any segmented segmented elbows, but you just put a deadhead Y, it's much worse for airflow. And then you go to Manual D, which is a duct design manual from ACA, and it'll tell you to add vanes inside, smooth turns. You can really smooth things out and make things a lot better for your life by smoothing out your turns in the duct system and just making sure you're thinking beforehand, if I was moving through here and this was pipes for water, how would I think this would work? Because the same thing, air is fluid in that way. Did I say air is a fluid? Did I say gas is a liquid? And I don't want to talk science on this show? Wow. Man, oh man. Okay. Let's keep on rolling. There's one more thing here. Static pressure, you must have the OEM blower. This seems like it's like people would not realize this. If you go to a duct system and you've been out in the field for a while, you're going to notice there are brand names on motors that you know go with a machine. Maybe you see an A.O. Smith motor or a Century motor, or all of a sudden, well, Broad Ocean now. Or maybe you see something like the, whatever the Watsco brand is, Best Tech blower motor. Excuse me, Ma. If you have a Best Tech blower motor, you are probably getting the wrong motor. It's not OEM. Not necessarily wrong as in airflow. It might be able to deliver the airflow, but you can't go to a chart for an OEM blower and expect it to work for some random aftermarket blower. You're no longer able to do static pressure that way unless that OEM blower is reinstalled or a new one is installed. So just realize that that thing has to be the one that came with it. And if you're wondering, you can always look at the data tag and compare what it says about the electrical information on the outside of a unit or the inside of a door, wherever they have put it. Check the amp rating, see if they match up. Just go from there. If you have a different amp rating, you know it's the wrong blower. And of course, you can call the companies, stay on hold for about an hour and a half, and then learn something that you wish you knew in 2 seconds. But you'll have to go to a different form of air measurement. Luckily, we're going to talk about some. Here we go. Vane anemometer. Now, the vane anemometer, as you can see on the screen here, if you're at the podcast, basically you see, basically it looks like a fan. And they can be really small, like 2 inches across. They can be larger, like this Testo one. I think it's Testo, I want to say it's a 417. You guys in the chat out there, if you know the right answer, feel free to tell me. But Testo 417 is just a really large vane anemometer. It's a really nice one. It gets a good cross section of air to measure, and basically air is either blowing across this thing or drawing through it It is blowing across it, but as a return, I think of drawing through it. And you're measuring how fast that air is getting through there, and then you're going to make a calculation based on how big the grill is that you are on, so you can get a CFM measurement. So this is handy, but it also has drawbacks. What's handy about this, it doesn't matter what blower is in that machine. It doesn't matter OEM, whatever, because this process is universal. As long as you can get to grills. There are drawbacks we'll talk about in a second. I use this process for a long time. I am in a place, I am in North Carolina. It's eastern, next to the coast of North Carolina, heat pump world. There aren't many gas furnaces here unless that municipality has had gas in there for a long time, like Wilmington, North Carolina. I would have done service calls there. And if you go to the older parts of town, you might have natural gas lines, and they have natural gas furnaces and natural gas packs. So you'd see some of that. Mainly heat pumps. But a lot of it is run either in the attic with the ductwork or in the crawl space. Nasty. But not all crawl spaces are bad. And basement? No. There's no basements here. Probably 2% of houses have a basement here in North Carolina that are located in my region. So you're not going to get that close, which is good for hot wire, which is the next thing we're going to talk about. But you just go to return grills, and you'll measure that, and you'll potentially have more than one grill to measure. So if you have 3 returns, you have to add those up and get your total CFM. It's a little bit more work because you're not right there at the unit doing it, but it's something you can do pretty much anywhere, at least in my area, and get a pretty good measurement, depending on the duct system again. If you're lucky, that thing, air handler, sits on a base box. You can go up to it and measure a grill that comes right off the base box. But that is very rare. That's your basement right there. And if there's a return in the basement, that's a problem. It's never going to happen is what I'm saying. No good things like that ever happen. So that's Vane Anemometer. See a lovely one on the screen there. I'm going to check the chat to see if you guys have said if it's the 417. You have not. You're doing a completely different conversation. That's fine. We'll get back to that in a second. That is what the chat does. They will talk about, which type of over-the-counter chili is the best. But that's fine too, because I love chili. Vane Anemometer. The drawbacks. You measure at the grill. Measuring at the grill, why is that a drawback? Well, the big drawback is the duct systems are not perfect. So if you have 80 foot of ductwork coming from that grill over to the unit, I bet it leaks. And you don't know how much it leaks unless you've done some sort of duct blaster test, which is not service tech land. Then you're going into I'm building for performance guy. You've left service tech land. I like to teach this stuff that is service tech related because I was a service tech at heart. That's what I love doing. I love fixing random stuff, challenges. That's right. That's why yours truly here. When someone said, you want to go on a tugboat and fix the air conditioner? I was like, yes, I do. It was not what I thought it was going to be. And it was not an abnormal system. It was something I would have seen every day, put in a very wrong way, which is, and I'll tell you this because we're talking about this not perfect world. So I go to this tugboat, and this will be a short story. This seems like it's getting off the point, but it really isn't. I go to this tugboat, and I expected some sort of water-cooled, like really cool Florida heat pump type deal or something on a boat. I don't know what I was imagining. I've never seen the AC on a tugboat before, or any boat really. But what it was a 7.5 ton Carrier split system. If that sounds insane, right? When you say it's like, no way it was that. Yes, that's what it was. It was in like a little hatch on the inside of this boat next to the stairs, of course, where you had to put a ladder like sideways to run it from the wall down to the stairs. That was where it was located. I'm pretty sure this wasn't made at the tugboat factory. I hope not. It has a tiny grill underneath it for return air, which was our problem that we ended up with because 7.5 tons of air, that is a lot. That is a whole lot. Let's see. If we have a 5-ton system, that's a nominal 2,000 CFM. So 7.5 ton is 3,000. Dang, that's going to have to be a pretty big grill. It was not. Talk about whistling Dixie. And those outlets got great airflow because there was only like 6 of them. That was a bad thing. So you got to make the best out of a bad situation on that. But that can be a hard measurement to make. Measuring at the grills can be tough because you have to have a little bit of dexterity in your hands because you're supposed to hold it a certain amount You're supposed to be even. Like you're measuring a grill, you're moving that thing along the grill slowly and trying to keep an equal speed throughout the entire run. Because a lot of these particular anemometers, they have time runs where you either run it like 30 seconds or you can run it as long as you want. You just start and stop, and then it'll average out that run. If you go real fast across the top, and the top of that grill has higher airflow, so to speak, and the bottom is less, which does happen on a lot of grills because you have orientation of the ductwork. If you change ductwork leading up to a grill or heading from a grill, and it has a bunch of bends right there off the bat, it'll definitely affect how the air flows into the grill. So if you don't do it evenly, you won't get a good measurement. Even if you get a good measurement, you have to worry about leakage. Now, coming from load calculations back in the day, I would expect to see like 5 or 10% leakage at least on a duct system. So you can always say, all right, I'm assuming that some leaked, but I would keep that low if you make that assumption, because you don't want to make it seem like your airflow is higher than it really is. Because if you say, I'm getting 1,000 CFM at the grill, and I'm sure there's 10% leaking, that means there's over 1,000 really, but I can only measure that because I can only measure what's coming through the grill. I can't measure what's coming through the seams in the ductwork or that big hole where they use the floorboards to pan something. That's one of my favorite things to do. We did that when I started the trade. We were the guys who did that. So in case you wonder when you're tearing that out, that was us. You're welcome. Those leak all the time because it's very hard to seal up metal screwed to the bottom of a floor joist. Unless you just want to spray caulk on it, just like fill the whole thing and make it look like Slimer from Ghostbusters. You want to fill that whole thing with caulk? But oh no, it's next to a pier. What are you going to do now? And that's what happened with all those things. It can be a problematic. So if you want to add like 5% onto it, that's something I think is reasonable. You can look at the duct system. If it looks like hell, you might be adding more. But the problem is you might be off by quite a bit unless you're measuring the leakage in the duct system, which we're not doing. Remember, we're on a service call. We're not measuring leakage. That's a different guy. If they want to measure leakage, all of a sudden we got Corbett. What's his name? I can't remember his name. Corbett, the guy who does all that BPI stuff. You got to hire him instead. Service tech, go home. Another drawback, you can face access issues. We hit on that here with this conversation. You're going to have problems. You can have problems with any one of these. I'll go back. Oh, not far enough back here. Static pressure, vane anemometer, hot wire anemometer. They all have problems. Let's skip to the hot wire. Now, hot wire anemometer, here we see a field piece one. You got this long metal probe with a sensor in the end. Basically, it's taking the temperature of that sensor. You have a hot wire probe. Just imagine it's hot, because that's the best way to do it. Let's keep it simple. And air moving across it cools it down. And however cool it gets, that's what the velocity is. That's how it reads the velocity. So what you do in the picture, excuse me, in the picture here for the podcast people, is basically what looks like a piece of spiral duct. They've cut a hole in it, and this probe is sticking through that hole. And what you'll do is you'll move it across the diameter of the duct. And you may do this in 3 locations because you want a nice look all the way across that ductwork. You don't want to measure one across the middle because that might be a dead zone. It's like, well, it's very slow here. But if you would have changed it and come at a different angle, and keep in mind, you're going across the entire diameter. You're not going to come in there and go across the middle, then through the top section and the bottom section. You're going to go all the way across at angles, up and down. So then you can get an average. Because these machines, I don't know if it's a field piece here, but I think it might be the field piece. I want to say STA2 or SAT2 or something like that. You can measure out a few runs and then calculate, which is really, really nice. And that works well. It's a really good thing, but here's the problem. See that piece of ductwork in this picture? That straight piece of metal ductwork? Well, let me introduce you to the South. The South has no straight pieces of ductwork that are longer than 2 feet before, and I'll just put this in terms that our Floridian friends down there, ductboard, metal duct, any straight duct. I mean, flex duct, I guess technically you could do it in flex duct, but that's a horrible mess because once you put a hole in flex duct, in between those 2 wires of the helix, it wants to rip open and then go all the way down that spiral on the inside, and then you rue the day you were born. You don't want that. So my experience is I had very little opportunities to measure with the hot wire. because it just didn't fit into the jobs that I had. Now, if you have commercial jobs, you may have the opportunity there because you may be able to have those long runs. But in residential, in a lot of places, you don't really have that opportunity. Someone in a colder environment where they have basements and you have that return stack coming down next to the furnace or air handler, you might be able to drill holes. Again, it was circular in the picture, but rectangular square ductwork, it's the same. You're drilling 3 holes across that full diameter, and you're doing these nice, long, slow runs with your hot wire, and it'll average them out. So that's a good thing. Just it doesn't really work in many parts of the country and on many jobs. So it's really for a specific type of duct system. But if you love the hot wire, I mean, I can't take that away from you. So basically I'm saying again right here, need a long straight duct. Metal duct is preferred. You can do it in duct board, but I really worry about duct board. When you're cramming probes through duct board, I'm imagining all those fibers just getting lodged in the probe. So you'd have to open it up and just be real careful with it. Anything like that, I mean, this field piece thing costs probably $300. You have to be careful with that because I know it's not $1,000 piece of equipment. It's not like a flow hood. It's not a CBS flow hood for sure, but it's not like one of these $1,500 flow hoods. But I mean, $300. I don't know about you guys, but to me, that's a good bit of money. $300 is a lot of money. I know that it's not a lot to everybody, but to a lot of people, me included, that's a lot of money. So I don't want to have to buy a new one or send it off for servicing. And then the guy calls you and said, been around duct board lately? And you're like, no. Why? And he says, I see your address here is Orlando. Orlando, Michigan? No. So it's a problem. It's just difficult. Don't let yourself get caught up in it by never doing it. Let's see. How do you draw it back? Oh, let's see. That's all airflow here. All right. Talking about all airflow. Measurements require some amount of setup and human input. Human input is basically, read that as opportunities for mistakes and wrong readings. You may have to go to a chart. Go to your chart for your static pressure. Make sure it's the right blower because there's several steps there. You got to pay attention to that stuff. Maybe you look in there and that blower is covered in dirt. Well, you're going to have to clean the blower, or your static pressure is going to appear too low, and you're going to say it doesn't have enough airflow. Well, it doesn't, technically, but not because it's the wrong speed. It's because the blower is covered in crap, and you have to clean it out. And that means a lot of times taking it out and spraying it down, hitting it with some of that coil cleaner that doesn't corrode stuff. Clean it up real nice, make it real shiny, and the homeowner goes, well, how much is it just to spray this thing off? Like, I'm going to be here for a few hours. This thing's going to be 300. And they're going to be like, well, just don't clean it. It happens to all of us. You have to explain what's going on there. Sometimes it looks like, they paid $300 for a guy to water their blower. You don't want that. Program duct area. So all these devices like vane and hot wire, you have to put in what kind of duct you have if you want to calculate the CFM. And you don't want to put in the wrong duct. And you want to make sure you measure it correctly, not say it looks like 12-inch round. You want to measure it correctly because it makes a big difference to what you're getting out. If you give it junk, it's going to give you bigger junk. Because every time you measure something, you increase the opportunity that the complete measurement that you want at the end will be bad. Like saying, I know we talk about measure volts, amps, you want to get watts. You got 2 measurements there leading up to another one. The capacitor formula that a lot of people use, which I never use, where you can, just measure the voltages and stuff like that, do a formula. I never did that because it's just more steps to get wrong. I stop the thing and measure the microfarads. Sometimes it shows up under load. Hey, there's an amp clamp you hook on that hermetic wire. Problem solved. Okay? Problem solved. It's the real world, everybody. The real world. Hand dexterity. That sounds stupid. It's like, what is this? Am I Hawkeye? Why do I need hand dexterity? Well, to move that vane anemometer around and the hot wire, you want to move at uniform speed. Because if you don't do uniform speed, you will have another wrong thing. And just imagine that. Just imagine moving your hand back and forth in front of you at the same speed. that can get difficult after a while, especially if you're doing it more than once, more than one grill. It's, it's one of the things where you're talking on the phone, all of a sudden you slow down because you're not paying attention. Wrong. Measurement's wrong now. Way to go. Your wife calling ruined the measurement. Shocker. That's just how it happened to me. It may be a different reason for you guys, but someone on the other end of a phone going, the car's making a weird noise, that will definitely cause your measurement to be wrong. You want to say, excuse me, I do love you, but I must call you back after this measurement. And then you're going to hang the phone up. It's going to click. And you're going to pay for that later, but at least your measurement's going to be right. And that's what you want. Airflow rate must be confirmed or all other measurements will be affected. It's the same premise. If you don't confirm the airflow, later on we do calculations of total capacity. It's not going to work. Every step has to be taken care of to reduce the chance of error. Is there going to be error? Heck yeah, there's going to be error. We're human beings. It doesn't even matter. If we were cyborgs, we still have a bunch of test instruments that have tolerances, plus 5%, minus 5%. You make 10 measurements with things that are plus and 5% tolerance. That all adds up to a much larger error. So try to keep it tight as you can, but you're not going to make it perfect. So if you want to make it perfect, you need to go to heaven. And there's only one way to do that is to grab a live wire and you can get a fast trip. You don't want to do that though. Things to do down here. Now, we say, I'm going to go back one here. Confirming airflow is just the first step of charging, capacity calculation, analyzing what's wrong with the system. It's got to be done correctly. And a lot of times it's so bad, it's so far off what it should be, you can say, well, I'm going to go and fix this because we can't check the other stuff, and you're going to cause yourself a lot of joy later where there would be misery. Superheat, subcooling, refrigerant pressures. Airflow changes all of them. You get low airflow, it's going to cause your superheat to dive, especially on orifice system, which is fixed, not a TXV, not a EEV. Any fixed system, orifice, low airflow is going to cause the superheat to dive. It may be zero. A lot of times if you have a junky coil, bad blower, you're going to be in a freeze-up situation real fast, but your superheat will dive. It's not as bad with TXV systems because they try to keep a certain superheat. But TXVs have parameters. They have tonnage parameters. If you have a TXV, it has 1.5 to 3 tons. That's where you got there. Once you get outside these parameters, it's not going to be able to do the job any longer. And you have to be able to say, okay, this TXV system can be susceptible to airflow, so I need to watch that. And the refrigerant pressures can go all over the place with airflow, too high, too low. So if you don't measure the airflow, none of this stuff's going to be right. Now, before anyone learned this stuff, they were like, okay, well, I charge the system, it's cooling pretty good, and they felt great. But now you can't feel good. You're going to have to fix it. You can't go through your life anymore saying, I'm not going to fix it. You just have to. This is part of life. Once you learn something, you got to go out there and actually work on it. And I tell you what, once you do fix it, once you get the measurements and you see that the system is performing or is not performing, you feel pretty good about yourself. And it's fun because we're nerds. Hey, I like science too. I got a beard. I like wisdom. All right. I want to know stuff. And you guys do too. Why wouldn't you be here? Now, I'm going to tell you guys that we had that poll started at the beginning of the show. If you're in here watching and you haven't voted on the poll, please go vote on it. What is your favorite part of HVAC? The science is still winning at 59%. 20%, oh, it just changed. People are voting. 19% from meeting and working with customers. That's admirable. 4% is selling jobs. Now, I'm glad somebody did vote for selling jobs. I was afraid that we were going to have a situation where the selling people would be shy because this podcast is very critical of sales. I'm not critical of actual good sales. I'm critical of sales done in that bad way that we know gets done because we've seen the guys. These slimy used car salesmen, the mold is everywhere salesman. Hey, here you go. I think I have a slide for this. Here we go. Salesman red flags. Number one is saying, I shouldn't be saying this. That means they're going to lie. And they're going to say something to make you feel like they're really concerned about you and to form a nice trusting relationship, which is false. It's a tissue of lies. Number 2 is a deal just for you. That's a lie no matter anyone saying that. Car salesman, anybody in the world says a deal just for you. That is also a lie, because why the hell would anyone do that? I'm going to have a deal just for this guy. I'm going to call it a Zack deal. It's plus 10% cost. Oh, what a jerk. Number 3 is salesman looking at people. Do you know about mold? If you say no, then they have a license to make up all sorts of stuff about mold. If you say yes, so you could say something benign like, I'm concerned that the stuff I found inside your air conditioning may be black mold. Do you want to take a look at it? Some people say yes. The nerds do. Some people say no. But a lot of times, they don't know what they're looking at either. Look like black dots on there. Okay, it's mold. When do I die? About tomorrow. You better buy the system. Number 4 is, yes, those are spores. A lot of mold stuff here. I've heard a lot of mold stuff in my career. I don't know about you guys, but a lot of salesmen talk about mold. And if there was the same amount of mold that these salesmen made it seem like, we'd all be dead or have respiratory problems. Every child would be in a wheelchair if we had this mold. Number 5, you need this Remy Halo. I just think it's funny because companies love to push crap like the Remy Halo. I'm not saying Remy Halos are bad. I'm saying companies, a lot of times they pick a product. It's like, this is an innovative product. We're going to sell all these fill in the blank to our customers, no matter if they need it or not. Hey, this guy's an athlete. He doesn't even run his air conditioning. It's off 365 days a year. You know what you need? You need a Remy Halo. No. And that goes back to sales tech. Sales tech is a single cell organism that feeds off of the ignorant. Don't be ignorant. Be smart. And don't be a sales tech. No sales techs watch this show. They will not. I had a sales guy that touched base with me years ago about coming on the podcast. I said, this is actually a great opportunity. This is what I told him. I said, we are very skeptical of sales on my podcast, and we'd love to talk to somebody, do it the right way. I don't know if he's going to do it the right way or not. I guess I got my answer, because he never answered that. He read it because you see his picture was underneath the message, but he never answered it. So I'm guessing that means he is a shady salesman. Yep. We have some new chatters down there. All right. Guys, I have closed out the educational portion of this show. We're going to go over to the chat where we can be ourselves. And we have 50 votes. Thank you, guys. There must be more people watching this show. I don't see the numbers on the screen because I have it blocked by my audio levels. But there must be more people watching, which I'm grateful for. Thank you. I'm glad you took a chance to watch the show. If you have a particular reason, like you saw the educational topic and you said, oh, I want to watch this one, and you enjoyed it or didn't enjoy it, I want you to put it in the comments. Not just a live chat. After the show's over, if you write it in the comments, it's really helpful for me. And again, if you want to show any appreciation, you can do a like. You can do the super chats. Just super chat your college fund for your children, and it will even out with karma or something. Randy says there's 32 watching. Thank you. Thank you, Randy. We have, we used to rock and roll. I love to be back in the day. Back in the day, we'd have like 150 people watching the show. Did that ever happen? I know we got to 200 one time, which is 50% of Chris Stevens. But that was pretty good for us. That was me and AK Greaves. If you guys know Greaves. A lot of newer guys probably don't. Greaves moved on to work for Navac. So that was a fun time. We got 200, man. I was super proud. I thought I was like Taylor Swift, that famous. It was awesome. But you know what? I enjoy talking to you guys. If there's 20 of you, that's fine. If there's 50, hey, that's fine too. If there's 200, I'll be like, this is awesome. But it's fine too. It's all good. So I'm going to go back and see if I've missed anything. Dang, I'm late. Good stuff here. Well, thank you, Matt Simmons. I appreciate that. If you're referring to the actual show, you could be referring to an internal conversation in the chat. Say orifices. I can't even say it one time. That's funny. Say orifice system 5 times fast. No. I remember seeing, Matt Simmons is talking, I remember seeing TXV hunting when I was new. May have been airflow, for sure. If you have, and I found this, here's learning the hard way. putting a nice 15 SEER, and this was a long time ago, 2009, 15 SEER system on bad ductwork. The TXV was just, it didn't know what to do because the airflow was so turbulent and poor that the TXV was trying to regulate a superheat, and it just couldn't do it. It was my fault. I'm super lucky I was ignorant and didn't know how to spot that, or I would have felt really bad. But as time went by, I also felt bad because I didn't have the capacity to change it. That's bad, but it's also human. We're learning. You may look back on and see things that, you know what, you miss stuff. You could review jobs in your head, go, I know I should have done this, I should have done this. It's only one way things happen. That's what I say when my kids say something like this. When my wife says it, I say, there's only one way things will happen, and that's the way they're going to happen. And you're not going to change any of that stuff besides doing right by everyone from now on. And if you get a chance to go back to that for anything, making whatever corrections you needed to. And maybe you just make some corrections there in the moment. Maybe you don't charge somebody. You go fix something else. It's like, I want to go ahead and adjust this airflow like I should have done a long time ago. You just do it. It's up to you. But, no one knows everything. So you can't beat yourself up about that stuff. Just do your best. And if you did something wrong, try to make it right if it's possible. That's it. Let's see. The show and the conversation. Thank you, man. I'm glad you liked it. Andrew is a nice guy. AK agrees. Andrew is what she's talking about, I think. I'm in and out of the chat, so sometimes they'll be talking about something. I'll be like, yeah, that's Greaves. I'm like, no, we're talking about Andrew Garfield. No, we were talking about Spider-Man. Greaves, awesome guy. Very complicated guy, too. I really enjoyed him. I never got to really delve deep with him and talk because, he was someone that was very interesting. He co-hosted Shop Talk with me years ago for just a few months, and then he got a job at NAVAC, so he moved on. But Greaves was the guy who was overseas battling in Iraq. He was back here trying to make a name for himself and his family, trying to make social media happen, just kind of growing, and just with a very complicated past. And what a cool guy. He was a great guy. I never got to know him as well as I wanted to, but he's a super guy. And you see him at trade shows. If you go out to trade shows, you see a beard. It's way longer than this one. His has been growing for like 10 years or something. And you see it at the NAVAC booth. Maybe he's showing you how to expand tubing or power bending. But you'll know it when you see him because he's the only one with a beard that's like 1.5 feet long. It's impressive, really. Let's see. Andrew's a nice guy. To go through some more. That's an R22 system. They're illegal. R22 system. No, they're not illegal. It's illegal to sell new R22 systems with R22 in them. And I don't know what they say about dry charge now. It's been years and years. But R22 is just a refrigerant they've left behind. And one day we'll only be able to think about it in our memories, which is too bad because it's a lower pressure and just better to work with, in my opinion. But, every refrigerant's going to be, the one you've worked with, and the ones now are awful. I think everybody said that. There's probably old guys out there going, I hate R22. Go back to R12 or ammonia or wind. He was referring to your sales guy list. Okay, yep. Okay, yeah. That's right. You should add that one on there. But see, I totally did that wrong. I should really stay tuned to the chat and maybe not answer things until they play out. Trying to add stuff onto the salesman red flags there. Okay. So, guys, I hope you've enjoyed this. I hope you really had a good time. I hope you thought it was beneficial. I really do. After years in the trade, I learned that there are certain things that you come at from a service tech. There's things that people teach you that may benefit you, but I'm trying to do it in a way that you can apply it to service tech life and installer life, especially if you're in the commissioning process of a system. So I hope you enjoy it. Guys, I'll be back Wednesday night. Wednesday night, we're going to play Skill Trade Up. We're going to have fun. We're going to give away prizes, answer questions. Remember, don't be like, I'm not coming on because I'm afraid I'll get it wrong. Everyone gets them wrong. Pretty much everybody loses because these guys will go for broke. You can stop during the game. You can answer like 2 questions, take a prize and leave. Or you can risk your prizes and keep answering questions. I think I'm going to do 5 questions, 5 or 6. I'm not sure yet. But these guys, they're risk takers. No one leaves. They keep pushing it because they want the big prize. And they don't even realize the big prize that's coming. They don't realize it. Dial a charge, guys. Bench. I'm just kidding. I do have one, actually, but no, it's not a prize. Tune in Wednesday night, 9:15, same time. Jessica, thank you so much. Jessica, been around for a long time. I hope I get to meet her. I'm assuming, Jessica, you're still going to visit the symposium, probably. I'm assuming that. I may go to the Brian Orr Symposium if I can. Someone said the tickets were sold out, but I'm willing to bet, since I am a infamous internet personality, I can get away to go there. I'm not going to be doing any seminars. I'll be watching with you guys. But I would love to meet a lot of you. Jessica's been a long time coming. I'd love to meet you. Bye, Felicia. Brandon, I wish you were there, man. It's a long way for you to go, though. I know you got to work at the cheese factory. Let's see. Have a good night to you. All right, let's get out of here. We can talk forever, but some of these people got to go to bed and work tomorrow. So I'm going to get out of here. Like I said, thanks for the support. See you Wednesday night. Skill Trade Up. Bring your trivia and your Wavos. Get on there and try to do it. It's a lot of fun. All right. I'm out of here. Love you guys. God bless all of you. See you Wednesday night.